Hello and welcome. I'm Bill Wake. We're here working on a basic interpreter with an eye towards turning it into a basic compiler at some point. And we're at the point where we've done a little bit of expressions and some simple print statements. But before going any further in that side, I wanted to go back over and work on we'd call it a REPL, a read eval print loop in from Lisp terms. Lots of languages use that language now, REPL, not Lisp. But basically an environment where you can type the program in and list it and run it for now, kind of emulating more or less the old style console-driven kind of basic. All right, now I'm going to review a little bit of sort of structure of the overall program, not so much the REPL, but just the way an interpreter works. So the interpreter is the big box. You have program text coming in. You do some lexical analysis, also called scanning or lexing, and that produces a stream of tokens. And then you do syntax analysis or parsing that's going to use grammar rules to interpret the stream of tokens and turn it into a tree of nodes. Then you're going to interpret those nodes. You're going to look a node at a time, do what it says, maybe do some input, maybe do some output, and then move on to the next node and interpret that, and so on. And what makes it an interpreter is it's kind of step-by-step working through the nodes, maybe repeating some work multiple times, the overhead of those nodes, whereas a compiler would produce eventually machine language that does the same thing. But rather than go into the code generation part, we're doing the interpreter part. Okay. Let's see. So I think, okay, I did leave Xcode up. Good. Okay, so where we left off, we've invented this program object that's basically keeps track of the lines of code in the program. And let's find, we have program tests. Okay, so we checked that we can add a line, we can overwrite the same line. If we look up a line that's not there, it says it's empty string, and if you just type the line number, you erase it. Okay, and I don't think we've hooked this up yet, have we? Content view. Well, let's run it. We just have we don't need the automatic updating. Let's do that. Okay, so we have a scroll view with a bunch of text, initially hello world, and then a text field at the bottom where you can type those line numbers. But on submit, all we do is print the thing. Okay. Where is it running? Is it running? Build succeeded. I thought I hit run. There it is. Okay, there's our hello world. We can type and we get this echoed down here. Okay, so this text is not our output yet. All right, let's get that going. Okay, and so what I'm doing testing wise, I'm not bothering testing the user interface per se. I'm testing the objects that it calls on, but I'm going to trust that I can just maintain a simple string here. Okay, and let's make this, yeah. Let's write this out here. Okay, so now we're saying write that output, and then I'm just for purposes of making sure everything's connected, instead of printing command, I'm going to append it. Well, I'm going to try. Okay. Oh, and we should clear that, huh? Okay. Oops. Okay, and new line I didn't put in. I guess we can do that. Okay, so this is all great, but it's not connected up to my program object. All right, at all. Um, what I want to do is, um, well, I'm thinking there may be another object out there. Did we create a REPL object? I really don't remember. Got REPL tests. Okay, there's REPL. All right. So it's got a program and execute it. If it's empty, it just returns. If it starts with a number, um, then it stores it in the program, and then if it can check that it contains something. Okay. Um, let's see. So I guess what we want to do first is let's get um, the typing and entering text connected. In a way, I don't want to spend any time on this because this is so primitive. It's really annoying. I mean, it is what you did back in the day, with those old basics. That's how they worked. But it's really annoying to edit with. So my proposal is, we'll get this version 1 done, do some more work on the interpreter, and then come back and maybe make this into an editor screen or something like that, just to keep ourselves sane. All right. So execute. Well, I guess the first thing we're going to do, let's say we want to. Well, it's interesting to me. I'm not sure how we want to do this. The easy way is if I just keep modifying that output string, but it seems like the REPL should own its own console, right? And this is where I get messed up. A constant state for me, as you know, if you follow me at all. Okay. Let's see. This is probably okay for what it is. We've not really changed anything here. All right, let's make sure everything's running test wise and push it if so. Okay, I didn't run these beforehand, which I usually do. Oh, and I can make this a little wider and a little taller. Get a few days off, and it's hard to remember how you manage things. Okay, something is. Oh, I'm sorry. Did I not set back to? Okay. Explains why the windows were out of whack. Alrighty. Tests all passed. Let's commit. Just kind of an immediate thing. Okay. The program, let's see, where's this content view. So what I'm thinking is the state. This really should be. What is it called? It's object. These things. I come back to it every few months, and I've forgotten what I did. Let's see, decked. I'm pretty sure Mander did it. All right, let's find our content view. Or was I that far off? All states. Okay, try another one. Well, sworn was a basic transliteration, so it'd be interesting if that did observed object. Yes, there we go. Okay, so let's look at swarm. All right, so we declare this as observable object, and the other one is observed object. Oops. Content view is observed object. So let's take that mechanism instead. Observed object. And a variable of a class. Variable. Let's do REPL. Okay, and then REPL has no initializer. That's fine. Okay. Generic group class. Yes, REPL must conform to observed object. Okay, in our swarm, all right, sorry, observable object. Okay, and where's the connection to trigger? I guess we can. We've got environment, and over here we looked at environment. No, swarm of swarm. Okay, I'm not quite seeing what something should trigger these updates. I don't know if that's we're automatic enough. Okay. All right, well, let's see where we go from here. Okay, so a REPL, and it's going to hold the program, but it also needs to hold the output. Let's give it the console. Set. Well, let's call it output. Okay. And in I should have left that open. In our view, let's find that. Okay, we did run swarm with swarm of the environment. Okay. I'm not sure where we're getting this. REPL has no initializer. Stored property output without initialized prevents. Okay. Okay. So that all has that. The content view, we want. I did mean to do that. Okay. Output is no longer existing. Okay, so now I think we can get to it. Okay. Okay, and I don't think we have to do any initializer work. We made everything, we gave it initial values and so on, so it's okay. All right, and it should run. Okay, we got hello. All right, so the REPL, I guess what we want to say is if you give it text, if you give it something to execute, it should echo the line to the output. Okay, so let's test that. So func test command gets echoed. If you say REPL.execute 10 print in a string, then, well, yeah, we'll keep with that. Let's say that REPL.output contains 10 print new line. Okay. I could be more specific. I'm just kind of ignoring the hello. This should fail. Yeah. Okay. Let me see. 0 to assert contains. No. Okay. All right, and into the REPL over here. First thing we'll do is we'll just echo that command. But append command and new line. Okay. Good, and let's run it and see, because I just don't know. Yay. All right. So our display is actually displaying. We haven't tested the scroll view aspect. I don't know if there's a way to force it to stay scrolled to the bottom when we get there, but let's check that in. Okay, so now REPL is connected to view, and REPL echoes commands. Okay, and what we've established is with our test, we let's make this one first. Again, I always try and tell a story, and I think the initial thing is, your commands get echoed. And then the second thing is, if you type a command with a line number, it gets put in the REPL knows it, Now, the contains is a little bit artificial, that it's there more for testing. We'll pay attention later and decide if we want to keep this method or not. But at any rate, you type commands. If it's got a line number, it gets saved. And then I think we're ready to do the list command. If, let's see, so there's sort of a command dispatch kind of thing going on here. let's extract this. No, you're not going to let me. Why not? Program is local. I don't think there's a good reason. Okay. Let's just call it a do line. Do line number. And I'll probably take the command in. I'll let the line number. Oh, let me put this over just a little. Okay. If the command starts with a line digit, then it must be a line number command, and we pull out the number at the front and store it in our program. Okay. Let's see. So the next one I think is list. We said we'd go there. All right. And this is kind of a two-step thing because we don't have anything on the program to actually list things, but list knows the program. So if the command let's see. Well, let's put some program in there. 10 print 42. And then we do a list. Okay. And this time I'm going to catch the whole output. Whoops. REPL dot output should be equal to we get triple quote constants here, right? Hello, 10 print 42, list 10 print 42. Okay, so hello is the initial text. That's the text we typed here with a new line. We type list, gets echoed, and then it should list the program. All right, and we're pretty sure that's going to fail. Actually, let me, well, okay, yeah, it failed. It's got hello 10 print 42 lists, but it didn't actually do any printing. Okay, and I'm going to do the, well, no, I'm not. Okay, let's support it. Okay, else if command equals list, then we're going to do list. We don't really need the command, but we do need the method. Do list. All right. Now we hold a program object, and let's see what we got. So program is a map String is probably not what we want. We probably want actual numbers. But anyway, all we do is get and set these things, and we don't have anything that walks through. Okay, so what I'd like to have is I'd like to have basically a list method that just gives me the output. Gives me the contents of the program. In the medium term, we want to get sorted order and all that good stuff. But let's start with this. Okay, we want a list method, and it's going to return, I think, a sequence. Do I say string like this? It seems like that messed me up the other day. So far, so good. Okay. Maybe not. Cannot specialize non-generic type sequence. Remove string. Okay. It's a sequence. I don't understand how it knows it's a sequence of strings. Well, sequence, if you were a sequence, you promised to have a next method. So sequence, this thing is not really a sequence at this point. Let's start with just array of string. Okay, and let's return junk. And make sure our tests, well, we didn't connect it, so it's certainly not going to pass. Cannot return. Okay, let's hook it in. Okay, do list. Let's return, let's do program dot list. Okay, dot for each. For everything in the list, I'm going to do output.append item and a new line. I don't think we keep the new lines in the... Oh, we don't keep the new lines. Okay. So I would like this to pass, but it's just going to return junk instead of 10 print. Okay, so it returned hello 10 print 42 list junk, and the program now is not doing its thing. Okay, so not surprisingly. All right, so the list, then we need to basically iterate through the program, and let's just do a bare bones version of that. Let's do program dot, is it values? I know it's something. I think you can say keys and values. No, values. Okay. Program.values. I think dictionary string.values. Well, let's see what that is. I have to do something else to it. Let's. Got a web browser here somewhere. No. Well, let's do values dot. Too many choices. I can map. Let's see what type this is. Dictionary string values dot element. I think we're okay. That should be the sequence's elements. Okay, it looks like the compiler's happy. Let's make sure the test runs. Notice we only have one line in the thing, so it doesn't care that it's sorted or not sorted or anything else. Okay. Are you running? Yes. Oops, that was interesting. Hello, 10print42, list 10print42 is not equal to... I guess I've got a blank line at the end. I thought this would do that. Maybe I gotta do this. There's a new line. Okay. All right. So we did primitive version of list command. All right. Now, this is not up to the job. Let me do one variation here just to kind of get this out of the way. Let's make sure that we convert this to uppercase before we compare it. Okay, should fail. Command dot to upper. Command dot uppercase. Okay. Oh, sure enough. Well, I guess it's echoing, so it's echoing. I briefly considered uppercasing it when I wrote it up there, but that's probably too complicated. Okay. Look for list in whatever case. All right. So what we have here, this I expect to be okay if program list does its job. What I don't think is true is that program list is going to do its job. Now, I mentioned before, I feel like this thing really should be int to string, that it should be keying off the integer. So if I say 010 line, is the line number, and then I type 10 as the line number, I really think that ought to be the same line. And we'll have to deal with this with goto as well, that it's going to get converted to an integer. But let's do this. All right. Now, this is no longer quite right. So if int new value, that's the set line number. Let me undo that a minute. Maybe I'm not understanding this as well as I thought I did. Oops. Okay. Int. Okay, so program sub line number is that line number is coming from REPL, right? Okay, it's numeric character. Oh, then we take out the prefix as a number. I can't convert it to int. string subline number. Oh. Okay, so we're taking the prefix of all digits, basically the leading digits, and line number. I'm worried about the type here. Seems off. String subsequence. Oh, we turn it into a string. Can I say int here? I don't think I can do it off subsequence. I'll give it a try. Okay, I know it's an integer because we just pulled digits. Now it should complain because it doesn't want ints. Yeah. Okay. Let's deal with it that way. Okay, so this is line number of int. This is int. Program some line number, yes, yes. Program room for key new value. What's the type? If int of new value equals nil, oh, if it's only the if the line consists of only a number, then we need to treat it as number. New value is still a string because it's the right hand side of the assignment. Okay. I may need an exclamation. Yep. And again, I know it's a number because this one failed to convert, so this one should succeed to convert. I kind of thought Swift would even do that analysis for me, but I guess it's not. All right, this should be okay. Oh, boom. Convert value of sprint. Okay. This should be an int. And then some callers should be upset. Yep. Yeah, it's unfortunate when we have to change an interface, and there are ways to do it more stepwise, like introduce a new one in parallel and stuff like that. But when I'm just changing 10-ish lines, I'm not too concerned. All right, let's see if we got everything. Good. Okay, so we store program lines by their integer line number. Now the program, okay, this is going to be hard to demonstrate. If I put the thing is, the dictionary can store items in whatever order it wants, and yet I want them pulled out sorted by the numbers. Okay. Let's try it and see what happens. Okay. It may take me some doing to figure out ones that are going to fail. Okay. List sorts by line number. Whoops. Okay. how do I want to enforce that? I may do it in a way that convinces me and then throw that away and leave it. I don't know. Okay, so I have 10 print 42. Let's put 20 print 22. Okay, and that should be in there. I'll put this back to list uppercase. Just traditional, I guess. This. Okay. Right. So my fear is this method passes already. So it doesn't control. Well, they get hashed and they get put in here, and we don't know if the hash function's going to put 10 or 20 first. All right. And then let's do one more. All right. So we're putting them in out of order up here for sure. That tells us something. They should come out in correct order. Okay. But this may well pass, okay, because we just don't control the contents. And it could come in any order. Build failed. Oops. Oh, good. Okay, 1025. 1025 is not equal to 51020. Good. Okay. Now, all right. So let's make it work, and then I'll play with it. Okay. So in this case, we just take the values. I think, is there an entries? Or maybe I can just map it. Okay, let's preserve this. Okay, so what if I just return program dot for map? Yeah, so map, the second one, I get the key and the value. All right, and the key's the int. Okay, so if can I sort them? By $0. Okay, so I'm trying to sort them. Oh, come on. Can I return expression dictionary int to return type string? Yeah, that's okay. I'm sorting them by their keys. Okay, and then I'm gonna do the dot values thing. Dot values dot map $0. Okay, so this part was arguing by $0 less than $1. I think I can just say less. Well, let's see what it thinks. Okay, values of dictionary T and element has no member values. Okay, this is we'll do a map. Okay. Ooh, is this even right? So, no. Kind of value of dictionary int string element key int value string to closure type. I think this is key value goes to value. Maybe that would be more. Oh, in. Okay. So take the program, sort it by I don't know if that's right. I feel like I lost a type here somewhere or something. Maybe less than is okay. Let's see what this type is. Is dictionary string dot element. Ooh. All right, let's make these lines, well, 5, 42, 22. They are kind of random. What is this again? It's a dictionary element. Let's be explicit. Okay, because I really do just want to sort by the keys. All right, so the key of the first element less than the key of the second element, and finally we get a key. The elements are key value pairs. We just want to get the value back out. Okay, and I think I could write this $0.1. Is that right? But looking at it, like, that's pretty obscure. I think what I had before is more clear, even though it's a little wordier. Maybe Swift people know that stuff so well. It's normal, but I think this will help. All right. Let's run this. Now notice we're not syntax checking anything at this point. This is a line. Another line. Huh. We're not listing it either. What happened? Execute list. Okay, let's go see our REPL. If the program command is uppercased, that is in the REPL. That's in our execute. Let's find our content view. We're not doing anything, are we? Oh dear. Okay, so we just did the echoes. We didn't execute the commands. So what we really want to do is REPL.execute command. And append is part of the REPL's job. Clearing the command is part of our job. Okay, let's try that again. So 77 print 25 another. 30. Another one. Yet another. Now list. All right. 125, 30, 77. All right. So it's in order. That's all good. We're due for a break, so let's take one. We deserve it. We got our list command running. All right. So about 3 minutes. See you then. Hello. Welcome back. All right. I can see I left a little slop here. Let's clean that up and run our tests. Good. And we have a REPL can store program and list it. Kind of minimal, but that's okay. It's a start. Okay, now, do I want to do I want to do the running program? I guess we haven't dealt with that. Let's find, okay, interpreter tests, BASI tests. Let's check this. Okay, so here we have a program. We give it to, we compile it basically and run it. Now, maybe, we don't actually run it. This is why I'm pausing. We run it from the perspective of the interpreter, but we don't really, we're not connected to anything. I don't know. It's independent, right? This output has nothing to do with the output in our REPL. And I don't know, I was pausing there about trying to make it a sequence because I really just want to have an object that people just say append to, and it's alive and being appended to. So maybe that's going to have to go through. The other thing is, let's close this. The interpreter, see, we have this interpret that looks at the parse tree. Okay, remember we talked about stream of tokens turns into a parse tree, and then the interpreter takes the parse tree and does it. And it's got a handful of things it can do now. It's got the lines. It reads one line, it skips, it prints, and we don't do anything about numbers yet. So we're very, very minimal. And I would like to move beyond this minimal thing. The other thing is we have this method that looks at the parse and does something. And there are other methods. We have other things that are going to want to look at the parse and do something. So like one thing is I just did all uppercase here, and that's sort of the standard way of writing this BASIC. And in those days, that was kind of the only way it did at some point. You know, they probably just had uppercase at one point. The standard way would be to show it with uppercase. And yet if you type 20, lowercase print 42, it really should normalize it. And then when we get to our compiler, the compiler is going to want to take the parse tree and, spit out other kind of code. I think we're just going to spit out Swift code and let Swift do the actual machine translation. But, again, there's another thing that wants to walk through the parse tree and do its thing. And there's a pattern for that. Design Patterns has the visitor pattern that knows how to walk a set of nodes, and you just define basically this part is not it's not part of, you don't need to worry about it. It just says you've got a method for each thing, we'll call it, okay? and that is good enough. There's also it's like all these threads, and I know I haven't explained them very well. Okay, also I'm not keeping this thing up to date. REPL list, we did finish that. This is number 6, May 17th, 2022, not 2002. Okay, so we've done that much today, for what it's worth. So I'd like to convert this to the visitor pattern at some point, but then also the program, this notion of lines, let's go to this program object. Okay, it contains a parse, an array of parses, and the line is just one single line of the program. Now, we talked a little about like how should the interpreter do it? Should it interpret a program or should it interpret a line? And there's some good reasons to maybe interpret a line. And I kind of want to come back to that one. Let's see. Also, I'm curious who uses this. Find in workspace. Okay. Case number of token. Number of float. This probably is an artifact that's not being used. Let's take it out and see what complains. I think it came about when expression didn't exist. Build failed. One place. Okay, yeah, and we don't even do anything with it. Okay, so I think that case is not relevant. Okay, so what do I want to do? Well, I can never tell if I'm just trying to put off the hard parts, and a parse that represents the whole program is maybe not relevant. That's the thing that's saying you got to parse the whole thing. And there are reasons interpreters like one of the reasons to use an interpreter, it's not so relevant to us, but in 2022, but one reason to use an interpreter is you can store your text as a pretty compact thing, and then the parse tree takes more space and is more elaborate and all that. You know, when you convert the whole program to a parse tree, you're probably creating, a very large object. Maybe it's 3 times as big as the text itself, or maybe 10 times, I don't know, but a lot bigger. And if you had a 64K or an 8K machine, whatever these small ones were, you didn't have space to do that. And so building up a whole parse tree was problematic. There are also reasons, just because you want to do things like trace line numbers or allow breakpoints or things like that, that mean maybe we want to work line by line and not worry about this. So I'm not quite sure which way to go, honestly, is the problem. And we're kind of merging together that front REPL program structure versus this, and I'm not sure I've got the right balance here. The other thing is this line, I think we can use the same kind of logic we did the other day where we turn number into float. We probably can turn this line token into an int, because we know that line numbers are ints. Okay, so let's see who uses this. Well, actually, let's do this. Let's just change it and then watch everything complain. Cannot convert argument of type token. Okay, so this is our parser, and we're looking for the integer token that represents the line number. Okay, so case integer equals token. So was the token an integer? Then let's let the line number equal the token and store that here. Well, token, we're switching to the actual int type. Let's go look at integer, our tokens. Okay, it holds a float, all right, which is the line number. We're going to convert that to an int. Okay, so let's, the line number is, let's say, token dot, how to do that? Token. It's body there. Okay, integer. Parse. The tests on the left. Okay. And parser. Got too much stuff up here. There's parser. Okay. Let's go down to our factor. Okay. In this case, integer, yeah. So we'll have to do a let kind of thing. Let's see. There's a way to do this all in one statement. I guess you can dig it up and learn it. Okay, if case integer let token int value. So we can put a variable here into value. Okay. That's the floating point number there. Let's let line number equal token. Well, let's let line number equal into value. And let's turn it into an int. Okay, it's converting from a float. Maybe it's just value. Okay. Or maybe I should be more explicit the other way and make it clear why it's converting. Okay. So if this case, if the line starts with an integer, we capture the float value from it, and that's the line number. And we will parse the statement and store the line number with the statement. Okay. I kind of feel like somebody else should be complaining. Like, who interprets the line? Maybe we don't do enough interpreting to make a difference yet. Okay. If you interpret a line, we ignore it. We ignore the line number. Okay. That's, well, it's not good enough in the long run, but it's good enough for now. All right, so make the line number be stored as an int. Okay, and what I'm doing, why I'm doing it, I'm nudging my existing code towards working with integer line numbers and strings for the right-hand side as the way I've stored it in the program. So that's driving things to be more similar, and that's an improvement. Okay. Let's see. Well, maybe BI-22 tests. We don't care about that one. Maybe this thing is the place to start. You've got a program. You get an interpreter out of it which does all the parsing, and then you say run. And then run puts the output somewhere in a big string. We don't like that either. Okay. And the reason here is you'd like to watch it run and put out what it's going to put out. The way this works is it gathers the whole string. So you can't have an infinite sequence and gather it, right? So I really do want output to work a different way. Okay, and so let's record that in our to-do. That's what we're doing. Okay. Did I check in? Yes. Okay. REPL run. Well, let's make running right to an output stream or something. It's like what's going to pass where, and I'm just not sure I'm at the right place for that. I mean, if it's observable, then something maybe does the REPL need to go down? That seems funny. And I don't know, it felt like in earlier projects when I tried to push more observable stuff down lower, it just seemed to be it doesn't do multiple levels. It's really designed to kind of do like this one level. Now, if I passed the REPL, I mean the REPL has this output string that is observable. If yeah, I'm just tangling. That's the problem. It's like the REPL knows the program. Is the program going to know the REPL? That feels off. Is the program independent? Oh, I just don't know. I mean, this thing being a string, like I don't care that it's a string per se. I mean, it's handy for the text field to print it. But, that's about all I can say good about it. I mean, really, I do just want to say this is some sort of append thing, append only even thing, and my program output should be appended to it. But if I hand the output to the program, I'm just doing string copies, and that's not good. Okay. Like, what experiment is going to make me happy? I could just pass the output down. If I pass the output down, it doesn't work. Okay. If I pass the REPL down, right. Let's create an append method. That would be helpful. Okay, so I'm kind of implicitly extract method on this. I want to say output.append. Oops. Copy. Okay, if I did that, this could become append. append. Okay. List. Append. All right, all my tests should pass. Oh, man. Convert value of type token to expected. Oh, I didn't run my test before my check-in. Not good. Okay. But I am simplifying my interface on the good side. Let's try that again. They should all pass. Okay. Am I muted? All right. So REPL, we extracted it out, append method, and cleaned up those tests. Okay. So add append method to REPL. Fix broken tests. Okay. Make running right to an output stream. Well, that's sort of what we're doing or heading towards anyway. All right. So if you I think the way this is now, if you did your output by saying append a string, then it would append that line to the output, the larger output string, and because this is an observable object, that would automatically update when this updated. Now, do I have to tag this? You know, I thought I did. Let's check a look at swarmed. Observed object here, yes. I don't have to tag the fields. It's weird to me because, like, most of these don't really get monitored. This really gets monitored. And we haven't really integrated that either, and that's a future thing. This module basically, I'm not sure where it is right now, but you'd think it would be, oh, it's in the dependencies. Okay, it should be there. All right. Now, so if somebody had a pointer to the REPL, maybe I'm just got the wrong maybe the output is the observable object should be a standalone thing. Okay. What it tells me at this point, I can pass a REPL in to my run. Okay, and let's go back to Parser Tests. Okay, so you pass in a program. Let's go find Parser. Okay, you give it a large string that's the whole program, and it runs the parser and lexer on them, and then it runs the interpreter on them. Well, it builds an interpreter and then runs it when you ask to run. Maybe this thing should not get the program as a giant string. I mean, at some point, this program should be the structure we use. And the fact that it's got the line number and it's indexed by line numbers, right? That's going to be what we want. If you say go to 17, it ought to be able to find line 17 and do it. And maybe this thing to parse the whole program at this point is not the right level. Maybe we should just parse line by line. Okay. How to reverse that decision in a clean way. Okay, so what I'm wishing, I guess, let's start there. I'm wishing that init took our program object. Okay, we can make that happen. If init took our program object, even if it immediately converted it to the kind of giant string it wants and all that stuff, I think we could connect in and work. All right, so let's work on program, and then later we'll work on an interpreter, like where are you writing to things. Okay, so program, I wish you took the program object. Okay, and if you did, you would have to let's let whole program, well, no, that's still program. Okay, let's let program 2 is, let's take program dot list dot I want to produce them interspersed with new lines. It's not map. Joined. Okay. Joined. Separator is new line. And I'm going to use program 2 here. Is that going to work? Okay. So if Parser took a program in our other sense, then it would work. All right. And this should fail to build, because nobody calls Parser with that. Okay. We are calling it with a string. All right. So let's go give program a way to let's let it do this. Let's let it, for convenience sake, we'll allow you to initialize it like that. Okay. and this init does not exist. Okay, so where's program? Oops. I don't know if I can make that thing go away. No. Okay. It should put it in the tabs here, but yoink is interfering. Okay, we'll live with it. All right. No initializer right now, but if it had one, it would look like this. Init string lines of string starts out empty, defaults to empty. Okay, so now this should be okay. Yes, let's do this here. So I'm getting it compiling, and then we'll make that piece work. Okay, that should fail because those tests don't really, program doesn't save it and do anything with it. So we've got to make program do a little work. Okay. Program. Okay, so I have to do that duplicated work. That's annoying. Do I want to mess with that? Was that REPL? Let's make this line for now. Okay. We'll dig out the numeric prefix. We'll convert that to an integer, store the line, and let's see if our tests pass. No. Oh, if it's empty. Okay, so if there is something in the line, then store that line. And let's run these. Okay, so what we've done is we've give program an initializer for an optional starting line and make BASI use program to get its contents. I don't know if that's coherent or not, but all right. Okay. All right. I don't mind this. That's reasonable enough. Okay. Sorry if I don't know if that background noise gets you. All right. So let's find BASI again. We're working towards getting this output, right? So I don't see it. Oh, over here. That time it took. Okay. A little clunky. But I think it's because we're running a little too far, maybe. We are parsing the whole program and running it. And I think that's a mistake. All right. The other thing is we don't have the output dealt with. But maybe that's... Let's see what run does. Interpret. It produces a string, and yet we ignored it there. REPL program. BASI. Okay. Oh, we just return the string it produces. Okay, I think we can do that. Even though we don't have the incremental stuff yet, we should be able to hook it up. All right, let's see what we got to do that. REPL. Okay, so what I'm trying to do now is run and make sure it does the run. So make running right to an output stream. We don't have that quite done. Let's do this instead. Okay, so let's do REPL run. We got REPL tests 2. Is that still... Why is that? Okay, I think we did some renaming and stuff and didn't go smoothly. All right, we want our REPL to actually run, so let's do that. Func test REPL run. Okay, so I think we can steal this much and that much. All right, and we want to REPL.execute run. And I guess we're going to get our whole console output. I don't know if this is super convenient, but that's what we got. Run should print 42 and a new line, I think. Okay, so I'm building in this uppercase thing just because we know we have to do it. Okay, so this should clearly fail. Okay, and it fails because it doesn't print 42. Okay. Now over here, we've got to parse our commands. So else if command.uppercase is run, then we're going to do run. Excuse me. All right, and how do you run? Well, BASI kind of lays it out. Actually, the BASI test, right, it lays it out. You create a BASI, you give it a program, and then you call run on it. Okay, not too bad. So let's create a BASI. With program. And we'll append result. Dun dun. Run. Hello, print 42. Run 42 is not equal to hello. 10 print 42. Run 42. Okay. That's not as helpful as you might imagine. I don't think I have any mistakes in here. No spaces. Why is that not equal? Forty-two, 42. Okay. I don't know. It looks the same to me. Could a new line character? Let's REPL.output.count versus expected.count. Something extra. 26 is not equal to 25. Is this... I think I just made it the wrong way. Yeah, 24. Did I have two of these? No. Well, that doesn't look like equal to me either. What is the difference? Is it this? Oh. I think it is. No? Okay. let's just print. REPL. But it didn't print my first character. Or it's a space. Print, well, one more print and then we'll debug it. That was friends. H. All right, let's just debug it. Oh, well, this is a lot faster, isn't it? Print REPL.output. Has an extra space after the 42. Oh, that is probably correct. This may not be correct in the long run, but I think, where's interpreter? The print statements do print. Always prints the space after the value. That's, do I want to embed that? Let's let's make it interspersed instead. Okay, so I think if you take values and you map them to format, I think I can say format, and then dot separated, joined. Space. Well, let's capture it. Okay, so we'll capture printed output as values. Map each one to its format and intersperse spaces, and then at the end append a new line. Okay. Result of append printed output. Okay. And let's see if this test passes now. Yeah. Okay, I think that's better. I think that's a better expression of what we want. Yeah. Okay. Let's see. So make run REPL run use BASI. Okay. And let's run it for real. Hello, 10 print 21 run, and there it is. Okay. That's good. Our REPL is running its stuff. Okay. We don't have the output problem solved, but we got REPL run working. Okay. Let's do that and check that. Okay. Now make running right to an output stream. I don't know. I'm willing to deal with programs that aren't infinite loops at this point. Although there's a very cute maze program called 10print that just prints a little one-liner and then goes to line 10. And it would be cool to run that, but you have to be able to deal with infinite loops. So let's shift gears back to expressions, and maybe we'll make this before we do the go-to. Let's do that. Okay, so we have a REPL. Let's take a break, another like 3-minute break. We'll come back and continue working on expressions and get those things put together. We've done the simple operators, the one character ones. We haven't dealt with unary minus, and I don't think we've dealt with the logical operators or relational operators. We haven't dealt with the complexity of tokens that need to handle multiple characters. And I had an idea for simplifying the tokenizer. It's less performant, but it would just be looking for individual tokens more directly. I don't know. Maybe we'll do it the traditional way. But let's take a break, come back, go back to expressions, and deal with print. I don't know if we're going to do this stuff. I'm kind of willing to hold off. I want to get the basic well, minimal kind of Turing completest things, although our numbers aren't big enough to make that possible. Um, but I think if we get expressions done and then deal with assignments, set up this running output, and then we can hopefully write the 10 print program would be kind of cool. All right, 3-minute break. Hello, welcome back. All right, so I'm gonna close out some of these things, just get us down to parser. Expression make, I don't think we'll need that. Token lexer, okay. So when we add things like operators, we kind of have to trace through each piece of this. We got to make sure it can scan, make sure it can parse, and make sure it can interpret. So the minus operator is already handled. So here we have minus. It's reading one character at a time. It sees a minus and it says, oh, I know what a minus is. It's a token dot minus, which is managed in a list. Okay, yeah. Here's one character operators, maps a character to a token. And there's minus. Okay, so that one's fine. How about the parser? Well, the statement structure, let's see, the grammar we have down here. Okay, programs goes to lines, lines goes to line number. Down here, print expression. Expression is sub-expression, relational operator sub-expression, or expressions with addition or subtraction, or multiplication, or powers, or it's an integer, a number, or a parenthesized expression down at the bottom. What we haven't dealt with is unary minus. So if you just had the value -3, well, all this stuff, works its way down to a factor, and it looks for either an integer, a number, or a left paren, but it doesn't look for a minus. So we need to add factor goes to, and then let's just do this. And I think, yeah, factor is probably the right thing. So just kind of recursive. You can have any number of minus signs. It's not going to interfere. There's no minus operator, so you don't have to worry about that. And that should be doable. Okay, so let's find parser tests. I guess we don't have it up here. Okay, there's function for parentheses. All right, let's do another one. Function test unary minus. And okay, we're not doing error checking, so it can be a little simpler, more like this. Okay. And I'm gonna take it really easy. I'm gonna use 3 minuses. Oops. Okay, I just want to make sure that minus 21 is all okay. Okay, and make this a throws. It shouldn't. I use an odd number because I want to make sure I can get a negative number out of this. And notice we allow minus signs here too in Swift. Okay, so if you have minus 21, that should be the same as minus 21. Parser.expression. Oh, it should not. We need some more stuff in our tree. Okay, because we're working from can we do a value like that? There's always a little trickiness here. Well, we don't have any unary operators at this point in our parse. Okay, so what we expect is a op1 token, which is unary minus in our case, and expression. Okay, so we really expect number 21, sure, but we expect dot op1 dot minus with dot op1 dot minus with, you can see the pattern, dot minus with number. And then close that one, that one, that one. And that one. 1, 2, 3, 4. Okay. And this should fail. Oh, yeah. Okay. We don't support anything on this now, so we're just going to say case op1. This is interpreter case op1 of let token, let expr, and we're going to do nothing. We'll just this for now. Okay. Oh, I guess I could return something. Okay. We're evaluating expressions. They all expect to return a value. That's fine. Fix. I think he's just behind. Expected number or left parenthesis. Okay. That's the error message you get when you don't follow the grammar. Back down here. Before we expected a number or a left parenthesis, now we expect a minus as well. Okay, or we could allow it. All right, so the parser for factor, if it's a left paren, it does something. If it's an integer, it does something. If it's a number, it does something. Well, we're adding a case here. If case dot minus equals token, else. Okay, so if it's a minus token, we need to return something. Okay, so what do we do? Well, we're going to consume the token. We'll skip past the minus token, and then we said the next thing was factor. So we're going to return, well, let's let value equal factor, and that's the method we're in. Okay, and then we'll return, well, it needs to be an op1. Okay, so up here, let's see, we return an op2. We're going to return an op1. The token was minus, and the value is the right-hand side. I'm confused. I guess we need try. I need a dot. Okay. Have I messed up these things again? Yes, I have. Ugh, I am just off my game here. Once again, I changed code and didn't check my tests, and we got extra spaces on the end of a bunch of tests, right? Let's check this one. 42, yep, extra space. Extra space. Extra space, which I'm really glad to get that off the end. I mean, it was a good change, but okay. All right. And the test we cared about, this test passes. Okay, so well, I'll check it all in. Let's make sure it all runs. Okay, so well, we fixed print tests to remove extra space. Added unary minus. To parser. Okay, so if we take, let's just take this much, and interpreter tests now. So we got to do our last phase. Okay, so let's print with equality, multiply, divide. I guess factors are up here. Simple print, print with value, with addition. Okay, I can fit in here. And test print with unary minus. Okay. Let the parse equal this. And interpreter. What's the matter? Member number. Type parse has no member. I think. Did I put it? Oh, this is expression. This should print without dot zero, I think. Do we not interpret? We have to make a program, I guess. I guess if I want it printed, I gotta have a print statement. Okay, fair enough. But let's see our interpreter. I mean, we could interpret do print. we could call evaluate. Let's do it that way. Oh, but I can't. Yeah, he really wants a parse. Okay. Well accommodated. I'm not sure that's quite. Do I care? What if I just did this? Let's make it expert. It's tricky to make sure you're testing things at the level you want to make them test at. I guess I haven't been doing that with expressions too much, but I'm saying I'm not going to worry. I'm giving it a kind of a null program, but I want to evaluate this expression, and then that evaluates that tree built out of that stuff. All right, this should fail. The parsing is okay, but the interpreting doesn't do anything yet. We get minus or just 0.0, and that's on account op1. Well, if with token in this place, okay, what do I want to say? Well, let's let operand equal evaluate of expert. Okay, and then operators subtoken is a two operator. It's a true operator with two arguments. This is our first case and only so far case of a unary, and maybe the only unary in there. So let's make sure if token equals minus, return minus operand. I think I can do this. If I put brackets in. And this, we're not doing throws out of these things, so I think we'll just leave this as a message. Theoretically, you won't be, no code you write should do anything but produce a minus. So I don't feel too bad about doing a print here. This is really kind of a can't happen unary minus. Wasn't unary minus. Okay. So I'm kind of leaving this representable, but I really do believe it can't happen. And maybe, like I could make this a negate operator that did the thing. Okay, but let's just go with it. Okay, and I think the compiler is just once again not caught up. Yeah. Okay, you see how much faster this goes compared to the REPL, where I have to worry about the user interface and how I hook in and reassess design decisions and all that. Okay. So we've got unary minus. Let's make sure all the tests run for a change. Good. Support unary minus in interpreter. Okay. Now, multi-character operators. Yes, valid. Okay, so the cases for those, we have the reserved words and or not, and we have the less than, greater than, less than equal, and all those kind of things. This time, we're going to start back at the scanner part of things and have some work to do. Okay, so well, one thing I kind of want to do, I don't know, maybe it's a distraction. Match while is really a match star kind of thing. It's matching 0 or more characters that conform. Excuse me, that conform to that range. And I'm going to call it match star for that reason. Is that good? It's really repeat 0 or more, repeat any, and repeat some would be the 1 or more. Repeat any. Okay, let's take that. I don't want to say match star because the star is an actual token and you could match it, and that would be confusing too. All right, now here we are with the operators. The 1 character operators we deal with, but we don't deal with less than, greater than, or less than or greater than. All right, so let's do a test. Elixir test. Okay, single character operators. Let's check. Let's see what check token is. It takes a string and it makes sure that the Elixir reads that token. Okay, so after the arguments, operators, before the numbers, we'll check these. Okay, so I can do them one at a time. I'm confident enough that I'm going to attempt to do it. Less. I don't have a less than yet. Okay, I'm going to attempt to do them all in bulk. Okay, less than. If you check token less than or equal to, less than or equal to, oh my goodness. This keyboard's a little too flat. And, oh, it has the bumps on F and J. Okay. I guess that's good. And not equal. That should have a dot. Okay, so if you just say less than or equal, less than or greater than. All right, and we need tokens. here, times divide all those things we don't have, case less than or equal to, case not equal. All right, where's our test? Lexer tests should be over. Well, they should be on that left panel. Again, it's not proposing it, so I'll just do it this way. These should fail. It should build now. Oh, there's probably some case statements that aren't exhaustive now. No? Okay. Not yet implemented. All right. In the Lexer, okay. Like down here, we'll say case less than. So they all three start with the less than character. We need to skip forward a character. Well, we know it's less than. We're in this case, so index plus equals 1. If, is it token? Let's see. Program sub index. If program sub index is a right parenthesis, a greater than, well, let's do equals first since we set them that way. Okay. Well, we skip forward over that one then. Okay. But we know it's dot less than or equal to. Okay. And else if program subindex is greater than, then we skip the character and we know that we return not equal. Otherwise, we read the less than, we set up to look at the next character. So, but we know it's not anything relational, so the less than itself is the result. Less than. Okay. And I expect this to pass. Okay. And same thing here. We're going to do case greater than, case greater than or equal to. All right. Now there's no greater than. Those are the only two things that start with greater than. All right. So let's do some more tests. We'll just add them here. Okay. So first one should be greater than. And greater than or equal to. Those two cases should fail. All right. Not yet implemented. And find our Lexer. Okay. And I'm just going to borrow it because it's going to be somewhat similar. And this duplication, it's, well, it's why people like parser generators, I guess, and token generators, scanner generators. Return greater than, or equal to. Okay, so we read the greater than. If it's followed by an equals, it's greater than or equal to. Otherwise, actually, we don't have an otherwise here. So we'll return greater than. Okay. And this is, it's basically a state machine kind of thing. We're just moving through the states and kind of leaving it set up for the next time. But I believe this should pass our tests. All right. That's the lexical analyzer. Now the parser. Well, we actually support that up here. Our top level expression, it knows to handle equals. So if it's equals, it let's see. So we've read the left sub expression. We've got the equals token and skip over that, and then we try and read the right sub expression and we capture all that in the op. We can just generalize that to any of these relationals. I know I must have some. Quality addition. Yeah, there's the quality. Okay. Boy. I want something programmatic again. Parser looks at program. Parser is make equals 1, 2. Okay. Let's call this func check relational. And we'll give it a token. Let it throw if it needs to. Okay, and I kind of want to do this. One plus. Oh, I can't. I guess I need the characters and the relation. Relation of string and the relation in token. So I got to do both forms. Relation plus that. Okay. And then in here, instead of equals, I want the token. Okay. And so this should be check relational with equals and dot equals. Okay, we'll just do both. Oops, I still didn't. Oh, I don't need the try. I don't need the throws, I guess. All right. 3, 4, 5, 6. And we got this already. Okay, we got equals. We got less than or less than. We got less than or equal. We got not equal. Greater than and greater than or equal to. Operator here is less than. Less than equal. or equal to, not equal, greater than, and greater than or equal to. Okay, so 5 of these should fail. I'm doing quickly here. And I'm just going to make another list. Let relops, and relop is so common. I just don't think it's an issue to use that abbreviation. So equal, less than, or equal to, not equal, greater than, or equal to. Okay, and that looks like a, left that one out. Okay. So, whoops. Relops is array of token. Okay, this test should fail 5 things. Build failed. Ugh. Okay. It does do throws. Okay. Oh, I suppose. Okay. Okay, I got my 5 failures. Equals passed, but number did not. Okay, that's as good a place to stop as any. So we're in the parser tests. We do not yet support the relational operators in our expressions. Okay, we only check for equals. All right, so we'll pick up there tomorrow, and we'll get the relational operators going and the and or nots. And with that, we're mostly through expressions. We haven't dealt with functions, which are definitely more of a pain, but we'll get there. But thanks for joining me today, and I hope I catch you tomorrow or in the future. Same time, which is Central Time, 9 to 11:30, Eastern Time, 10 to 12:30, and UTC 3 to 5:30, I believe. So thanks again. Take care. Bye-bye.